Let's take a look at this proportion problem. A state university claims that approximately 60% of the students drive to school. A statistician took a random sample of 200 students, calculate each of the following probabilities. So the z-value rounded to 3 decimal places, the probability rounded to 4 decimal places. So this is definitely a proportion problem. So first of all, they gave you a population proportion. They said that 60% of the students drive to school, right? So this is 60% of the entire population. So we know that P is equals to 60. All right, and then they give you a sample size, n is equals to 200. Let's take a look at the problem. They are asking you to calculate the probability that at most, which is no more than 100 of 200 students. So when they put the words like that, this is clearly a proportion problem, right? First, you see a population proportion. Second, you see two numbers that helps you to set up a fraction. So for the sample proportion, we have x divided by n. So n is the sample size, 200 students, and then within the 200 students, we have 100 of them, 100 out of 200 drive to school. So we know that the sample proportion is 100 over 200. So I know this proportion is easy to reduce. You can reduce that to 1/2, you can reduce that to 0.5, but when you solve proportion problem, it is not necessary to reduce the fraction or put it in decimal form at all. So let's move on to the standardization. So that is probability. They are asking for the sample proportion that is greater than, right, at most, less than or equal to 100 out of 200. And then you start the standardization process. So this is a z less than or equal to, you take the sample proportion, 100 divided by 200, and then you subtract the population proportion, and then divided by the square root of 0.6, 1 minus 0.6 divided by 200, right? N is equals to 200. And then let me show you how to calculate this big operation in your calculator. So first of all, for the numerator, here is how I do it. I start with a parenthesis. Okay, but for the 100 divided by 200, I use another parenthesis. And then close the parenthesis minus 0.6, and then close the entire parenthesis for the numerator. All right, you might ask me, hey, why do we have to use 100 divided by 200? Why don't we just put a 0.5 divided by 0.6? Because sometimes you get a sample proportion in fraction. When you take the top divided by the bottom, you might have to approximate that fraction. When you do an approximation, you accumulate round-off error. So I do not want to accumulate round-off error, so I put the entire fraction to my calculation. And then as you can see, look at my calculator, I have a parenthesis for the 100 divided by 200, and then another parenthesis for the entire numerator. So this is very important. When you do proportion problem, make sure you use the parentheses very carefully. And then you divide by the entire denominator. It starts with a square root. You do 0.6 and then times 1 minus 0.6. You must hit the multiplication symbol, otherwise the calculator doesn't know that you want to perform multiplication, and then divide by 200. So that's how I do my approximation. So this one, you have the z is less than or equal to negative 2.887, right? So 2.887, and then you draw a graph. So the graph is a bell curve, and then you have 0 right in the middle, and then negative 2.887 is all the way on the left, and then less than, so you have a piece of probability on the left. And then how do you approximate this probability? To approximate this probability, you will have to use normal CDF. So that is equals to normal CDF from negative infinity to negative 2.887, and then the mean is equals to 0, standard deviation is equals to 1 because we have a z is standard normal, mean is equals to 0, standard deviation is equals to 1. Let's find out what the probability is. So you go to second vars, normal CDF, -1, second comma, 99. So this is negative infinity. If you don't know how to type this, let me say this again. Negative. The negative key is between the decimal point and the enter. -1, right? And then how do you type the E? The E is you type the second key and then you type the comma. Comma is right above 7. So that gives you a base 10e, and then 99 is the exponent. So that is -1 times 10 to the 99 power, which is -1 followed by 99 zeros. All right, so we treat that as a negative infinity. And then the next number is negative 2.887. Please type negative. The negative key is between the decimal and the enter. And then 0 and then 1. So the probability is 0.0019. So this is the answer to this question. And then there is a shortcut to type one command to get straight to this answer. So let me show you that one. So that one is normalcdf. You start right at the sample proportion. So from negative infinity to 100 divided by 200, and then the mean is the population proportion, and then the standard deviation is the square root 0.6, 1 minus 0.6 divided by square root of n. You can call that standard error. So this one, let me type this in. Second vars normalcdf, a lot of typing, right? -1, second enter, not sign, second comma 99, so that is negative infinity, and then the 100 divided by 200, and then 0.6 is the mean, and then comma square root 0.6 times 1 minus 0.6, or you type 0.6 times 0.4 divided by n. The n, I wrote n, it is supposed to be 200. And then divided by 200, and then you close the entire parenthesis, you hit enter, then you get the same probability. I know the probability is a little bit different, right? If you compare the last few digits, the reason that you have a minor difference is because this z value, you round this up. Again, every time you round, you accumulate some round off error. The yellow command, the probability that you obtain from the normal command has no round off error at all. All right, so this is the shortcut command to get straight to the probability without showing any work. Which one should you do on the test? If that is a written exam, you have to show all your work, then you follow the purple work. If that is a multiple choice, you do not need to show any work at all, then you follow the yellow command. Okay, no need to show work, follow the yellow. Need to show all the work, follow the purple. Okay, so that is problem 1. Let's move on to problem 2. We switch to another color. Problem 2 is no less than 100 out of 200. So part B, the sample proportion is x divided by n, that is 150 divided by 200. They are asking for no less than. No less than is probability p hat greater than or equal to 150 divided by 200. And then you standardize that, so that is z greater than or equal to, you have 150 minus 200 and then minus the population proportion divided by the square root 0.6, 1 minus 0.6 divided by 200. And then let's see what that equals to. So we have open parenthesis and then open another parenthesis, 150 divided by 200, and then subtract 0.6 close parenthesis divided by second, and then type the x squared key to get the square root 0.6 times 1 minus 0.6 divided by 200. And then that equals to 4.330, right? And then here is the graph. So 4.330 is so far on the right. So it's almost like right here, right? And then the probability will be extremely tiny. So this one, the calculator command is normal CDF. You go from 4.330 to positive infinity. The mean is 0. Standard deviation is 1 because we are using z. Okay, so let's see what that equals to. So second vars normal CD, no, not inverse, not second vars normal CDF. You go from 4.330 to positive infinity 1 second comma 99, and then the mean is 0, standard deviation is 1. So this one is, do you see that there is a E -0.06 at the end? This is a scientific notation. 7.46 times 10 to the -6. So that is 0.50. 746. When you see this type of probability, you will see this again in the future chapters. That means the probability is very close to 0. This is a scientific notation. The way that the calculator expresses the answer is scientific notation. This thing shows up in statistics a lot. All right, what about the super shortcut command, the one that you don't need to show any work? So you do normal CDF. You go straight from the beginning. So you start at 150 divided by 200 and then to positive infinity. The mean is 0.6 population proportion. And then the standard error is 0.6. 1 minus 0.6 divided by 200. So that is one step to give you the final answer. Let's take a look. Second verse, normal CDF, 150 divided by 200, comma, 1 second, comma, 99 for infinity, and then 0.6, comma, square root, 0.6 times 1 minus 0.6 divided by 200. So that is 7. You still get 7.45, right? Times 10 to the -6. It is a little bit different than the previous one because the 4.330, you round this. Every time you round, you accumulate a little bit of round off error. The more you round, the more errors, the bigger errors you will get. All right, so that is part B. So which one you should do on the test? If you need to show all the work on your exam, follow the blue. If you do not need to show any work, follow the yellow. All right, that is clear. And then the last one. The last one is between 110 and 120, right? Yep, between 110 and 120. So C, using the same sample size, I remember that. So we have 110 divided by 200 and 120 divided by 200, right? So that is probability 110, 200 less than p hat, and then less than 120 divided by 200. Let's standardize these two fractions. So that is 110 over 200 minus 0.6 divided by square root 0.6, 1 minus itself divided by 200, less than z, less than 120 divided by 200 minus 0.6 divided by the square root of 0.6, 1 minus 0.6 divided by 200. So let's approximate these two z's. So in your calculator, start with a parenthesis and then start with another parenthesis. Put the 110 divided by 200 in a parenthesis and then minus 0.6 and then you close the entire parenthesis. This is a skill that you will have to learn. Okay, divided by second square root, second x squared to get the square root. Now, I want you to check your work. Did you use the parentheses carefully? Compare mine and the one you type. Did you get it right? If not, go back to fix it. If yes, then we continue. 0.6 times 1 minus 0.6, close parenthesis, divided by 200. And then you hit enter. So you have a negative 1.443, right? And then for the other one, I know you hate typing this all over again. Now, watch. Type second and then enter. So the previous entry shows up and then you use the left arrow, move the cursor to the 1, the 110, move the cursor to 1. Make sure the first one on the left is flashing, right? And then you override this. You override the 110 to 120. And then you press enter. There you go. You get the other one. So the other one is equals to 0 because 120 divided by 200 is equals to 0.6 exactly. So 0.6 minus 0.6 is equals to 0. 0 divided by a non-zero denominator. So the z-score is equals to 0. And then we calculate this probability. Let's draw a picture first. I like pictures. You have a 0, negative 1.443, and this is the probability that you are looking for. So you do normal CDF from negative 1.443 to 0. Okay, the upper limit is 0, and then the mean is equals to 0, standard deviation is equals to 1. This 0 is from here. Second vars normal CDF, negative 1.443 to upper limit 0, the mean is 0, the standard deviation is 1, the probability is 0.4255, right? So this is the probability that you are looking for. What about the shortcut? The shortcut, let's do it in yellow. So the shortcut, you start right at the sample proportion. So that is normal CDF from 110 over 200 to 120 divided by 200. The population proportion is 0.6. The standard error is square root 0.6. 1 minus itself divided by n. So that is one step to get to the probability. Second vars, normal CDF, 110 divided by 120, 120 divided by 200, 110 divided by 200, right? And then 120 divided by 200, and then 0.6, and then comma, a lot of typing. That takes practice. That's why you have to do your homework. 0.6 times 1 minus 0.6 divided by 200. See, you get the exact same thing. Not exactly the same, so the 425 are the same, but after the 425 there is a minor difference. The reason is this is around, you round this, you round the negative 1.443. So you round that z, you accumulate a little bit of round off error. So that's why the two probabilities are a little bit different. But as long as you round the z to 3 decimal places, you round the probability to 4 decimal places, that would not affect the answer at all. Trust me. All right. Which one should you use on a test? If you have to show all your work, every detail will be graded. Follow the red. If you don't need to show any work, follow the yellow. So it is just that simple. All right, so that is the end of this video. If you think my explanation is helpful to your learning, let me know in the comment section below. Subscribe to my channel, like the video, share the video for me. I appreciate your help. I will see you all in the next lesson. Signing out.